Recording in progress.
Okay, those are the answers for number one. Yeah, you could kind of do. I mean, yes, to tell you what to do. You have to do a table. You have to sketch a graph. I mean, either technique will get you the answer. If you make a table, I would suggest you plug in like values close to 4, like 4.001, 4.01, 4.1. So kind of work your way closer to 4. So from the right side, 4.1, 4.01, 4.001. From the left side, 3.9, 3.99, 3.999. That's 3 nines, I think. Personally, when you really do this numerically, just plug in any number super close. You don't have to plug in like 6 or 10 numbers or anything like that. You know, just 4.01 is kind of good enough, and 3.999. Likewise for B, like 2.999, 3.001 is good enough. Graphing it, that's pretty obvious. If you use Desmos, it's totally fine. Yeah. Or graph calculator, Desmos is probably a little easier. So those are the answers for those limits. F is 2/3, by the way, which you can actually factor. And then if you know your difference of cubes, you can actually get the factoring done pretty nicely. Questions on these right here? Yeah, Clay, go ahead.
Wait, can you?
I could do it right now. Yeah, sure. See. Okay, y equals ln. I got it. I got it right in front of me, man. Yeah, because at this point. Oh yeah, I trust. Yeah. It's fine. Okay, yeah, there's your graph, right? And x is approaching what, 0?
Yeah, I see how it's.
Yeah, that's 1. Yep. There is actually kind of a cool technique to do this analytically. It's called and maybe I might correct you guys this semester. It's a French mathematician. Oh, how do you know that?
I didn't see the part where it says graph.
Yeah, what you do is you wind up taking the derivative of both top bottom. I have not taught you guys derivatives yet. We are going to do that in our next unit. But in case you guys are curious, whenever you get 0 over 0, when you plug in whatever the limit's approaching, so x is approaching 0, obviously. So you have natural log of 1 over 0, which is 0 over 0. Whenever this happens, you have an opportunity to do this rule, which involves a derivative. But again, I have not taught you guys derivatives because I have to make sure you guys fully understand limits before we get there. Because derivatives are based, excuse me, are based upon limits. There's a limit you use to help you find a derivative. We're not there yet, but just in case you're curious, we will be able to do that analytically when we get to that point, and it will come out as 1. So that's something that's on deck. Anyway, that's number 1. Anything else but number 1? We're okay. We go. All right. Number 2. Here we go. Let me clear a screen. That's just looking at a graph. Should be d for most of these, right? If you do say positive infinity for a and e, that's totally fine. I'd accept that. What was that? Sorry.
They said that when it's infinity.
No, true. As I say, both are valid. In my eyes, both are valid because you're being a little more explicit if you say infinity, right? But technically speaking, true, it does not exist, right? Because what is that number? I don't know. Now, you can't say that for x approaching -2. You can't say this right here. You see, negative for part B, that's 2-side limit, right? Since it's a 2-side limit, here's the problem: that one side's going down, one side's going up, so they don't meet, right? There's no agreement, so you have to say d in that case. You can't say plus minus infinity. That's weird. But for a on the left side, the right side of -2, it's going up forever. So you can say positive infinity. That's fine. But of course, d is kind of the good, safe answer. So if you're risk averse, I don't know. So does that make sense? Okay, cool. And then for 3 and 4, those are those right there. We had that crazy thing with part B. Yeah, does not exist for C because they're both going different directions. A, of course, they're approaching different numbers. So that makes sense. Ethan, go ahead, yeah.
I have a question for part B.
Yeah.
I don't understand why like limits for those does not exist because even though like the spiral was like like goes up and down really quickly, right? Isn't that still continuous? Like, shouldn't that still like?
Okay, but we don't know. But as x approaches zero, but I don't know what it's going to be though. No, you're right. There's no breaks. That's what you're thinking, right? There's no like point removal discontinuities or vertical asymptotes, things like that. However, well, technically you could say it's vertical asymptote at zero.
It's like for zero.
You can't divide with zero. But as you get closer and closer to zero, I really don't know what y is approaching.
Okay.
Right? Because it's just going like this as I get closer and closer. Because like, what if I do 0.00000001? Okay, that's like cosine of like 10 million.
Isn't that still like solvable though?
It is, but I don't know what it's going to settle on. It's not going to settle at a certain point as I get closer to zero.
Oh, okay.
0.0, another 0.
It's so unstable. Put it this way, it's incredibly unstable. The graph shows that. So, I mean, I could go to a graph calc. Actually, I should pull it up, regardless. 'Cause I need to pull it up for today.
It's still considered like not continuous.
Correct.
Just sounds-
Yeah, because it's not following the rules of continuity. Because first of all, it's not defined at x equals 0. That's one problem. Which we're going to talk about later in the unit, and also the fact that I have no idea what the heck the limit is. I don't know. Yeah, but like if I were to do this, like what was it cosine? Hold on, what was it? Straight up, it was cosine 1 over x. Yeah, so if I were to do cosine of 1 over x. Oh, by the way, one thing, guys, I should caution you about in calculus, we hardly ever use degrees. Rarely. So make sure you're keep things in degree mode. Sorry, keep things in radian mode. We'll talk about that when we get to derivatives, but never ever, not never ever, but rarely do we ever use degrees. So just keep that in mind. But yeah, if I do a table, so let me set it up. Yeah, 0 is fine. And let's make that like 0.001. And if I actually look at the table, yeah, you see those numbers just kind of just go all over the place, right? So I'm not really sure what to think of this. Like it's like, I mean, what's the maximum cosine could be? Is 1, right? So we'll never exceed 1. But the thing is that because your input is just so crazy, right? The periods become narrower, right? Way narrow. And so, yeah, it's just gonna do that with this really kind of crazy oscillation. All right. Then for 5, I didn't have the answers. I don't know why I didn't have it last year. That's really strange. But I'll just tell what the answers are right now, because I worked them out. And I could work on it in detail if you need me to. And if I'm wrong, let me know. I'm not perfect. I did this in about like 6 minutes. And I was really lazy because I didn't write the limit notation. I just wanted to just get the answers. I got -5 for this one. Yes. Okay. I got 2 for this one. Okay. I got -1/9 for this one. Yes, no. You're correct. -1/6. Okay, I can say 3 times 3. Good. That's why we're checking. 5.
Yeah.
1/4.
Yeah.
-1/8. And 1/6.
Yeah.
Okay. Any of these would you like me to work out? At all? Yes? Yeah, no problem at all. So for C, oh yeah, that's a good one. So again, don't get lazy. Yeah, write this, right? Now, here's what you're gonna do. You see what I did with the top? Yeah, you could do that because if you put negative back in, it gets you back to the same thing. Now, what happens to x minus 3's? Go away. What are you stuck with up top? -1. Again, don't get lazy. Do not get lazy. Then plug in 3, get -1/6. Okay, everything else is good? Yeah, go ahead, yeah. Sure. No, which one? Yeah, please. Which one? G, yes. That's a good one, actually. You know what? I didn't do this with you guys because I did ask you guys to watch the video if you could. I'll talk about it again if you need me to because I didn't finish off those notes. I did it with A period though. Because I usually teach better with the second class. No, just kidding. Sometimes I'm better with the first class. I'm more organic with. We may have to actually the week of March 10th because actually I'm going to talk about that because that's a 4-day week and so things get flipped again, which is so annoying. Even next week is weird because we have Ash Wednesday, so we don't have assembly next Tuesday. So I can't play volleyball again, which is really unfortunate. No, just kidding. No, I didn't play much. Yeah. I think give me a chance, man. We would like won all the games. Really good.
Can you do E after you do G?
Sure, I'll do E. Yes, yes. So anyway, so going back to G again. So what you could do a couple things actually. You could let me back up a little bit. For G, you could combine 9 over x squared with -1, because -1 is 1 over 1, right? And what's the least common denominator? X squared. So multiply top and bottom by x squared. You could do that. Find your LCD and combine these two, which becomes this, right? But then you have a complex fraction, because then what you have is 9 minus x squared over x squared all over 12 minus 4x. I'm going to factor out 4, by the way. And that's over 1, by the way. See what's happening? We have a complex fraction. You have fraction over fraction. How do you do that? You flip this over. This is why we did this to you guys in Algebra 2. We give you these kind of problems so you can feel comfortable doing this in calculus. So a lot of times in Algebra 2 students like, why are we doing this? It's like, well, yeah, because you do calculus, dude. That's why. So anyway, so I was kind of condescending. So you do this, right? So you do that. And 9 minus x squared, you could write like this, right? And what cancels? The 3 minus x's, right? So you wind up getting 3 plus x over 4x squared. And I'm totally getting lazy. I apologize. So that's 6 over 36, which is 1/6. So you can do it that way, where you combine whatever's up top and then the bottom, just deliberately make it a fraction by putting over 1, flipping it, factoring, simplifying, all that fun stuff. Or a more efficient way, I feel, is find the LCD for everything, both top and bottom, which is of course x squared still. But if you just multiply the top by x squared, you wind up getting this, right? Then the bottom becomes this. And actually, let me factor out the 4 while I'm at it. Then you can break apart the top and cross stuff out. That's a fair treatment, because what are you doing to both top and bottom? The same thing, right? It's fair treatment, because you're really just multiplying the entire thing by 1, and who cares what that is? So, yeah, so you can do that too. And then finally, yes, Ron, good.
For like all those steps you were doing, you have to write limit x as x perfect.
Yeah, I know, which is why I like this a little better, because you don't as many times. Yes, you do. For E,
I figured it out.
you did a conjugate.
You know, yeah, I
Okay.
did the conjugate, but I realized I added +1 instead of I added +1 instead of a +2 on the bottom.
Got it. Got it. So you just made a careless mistake, which happens. Yeah. Yeah. Because the whole intention is to get rid of some stuff up top. So, well, actually, to get rid of x minus 3 on the bottom, but you have to get x minus 3 up top to get it to cancel out, or something like that. So, okay. I think we're good on that. All right. So let's go to the notes. See how far we can get. And I do want to make sure there's time left for the quiz. So I say around 9:10-ish. Quiz I don't think should take more than 7-8 minutes, as long as you're comfortable with the calculator. But some people might need 10 to 12 minutes. So let's see how far we can get with the notes today. I think we can get pretty far. So we're doing more on limits, okay? And these are some limits we just have to kind of accept, and we kind of saw it in the homework. Yeah, what's up?
Let me spray notepad this. I have to look mine up.
Yeah, because I know you forgot.
Thank you.
No, just kidding. I always make like 7 or 8 extra ones. There we go.
Nothing else.
Yeah, no problem. Thanks, school. It's their money. Well, it's your money. You're paying for it. So, this is weird because we didn't do this in the homework, right?
Yeah, that was in the homework.
Was where?
Totally.
Oh, C, duh, and G. I totally missed it. Sorry. Yeah, I didn't. I just glossed over the answers, right? Okay, you're correct. You're correct. Yeah. So here's what happens. Really?
Oh, sorry, my just going to what page are we on?
Page 9. Page 9 on the PDF. Yeah. Okay, so why is this true? If you think about it, as x approaches 0, sine x is roughly the same as x. for example, if I go to a calculator, and you have to be in, again, radian mode, and there's a reason why it be in radian mode. That won't be clear until we actually start doing derivatives later in the spring. There'll be a formal derivation I'll do, but like, let's say I do sine of 0.01, right? That's pretty close to 0.01, right? What if we just sine of like 0.00001? It's pretty much going to say the same thing with just scientific notation, which is just doesn't feel like rounding it, but sorry, being more precise, it's rounding it. So that's what we're noticing. So what if I do like sine of 0.05? I get roughly 0.05, right? Yeah. What if I do 0.005? I got that. If you did a negative, I think it would be slightly bigger. Yeah. Now, what if I did sine of negative 0.005? There we go. Right, that's slightly bigger, right? I know it's kind of weird because it's negative, but it is slightly bigger. So we're going to see the same thing happening here again. That's going to be 1 and 1. So when this happens, those are each 1. And another way you can think about this too is you can do something called the U sub. Or I don't know why I use the letter U. That's just what textbooks use. You can use like any letter, I don't care. But what if you did that, right? Then how would I rewrite this? I'd rewrite it as the limit. Now, remember, if u equals 5 over x, what would x equal? U over 5, right? And if x is approaching 0, then what's u approaching? 0 also, right? Yeah. So if you were to do a substitution, isn't that just the same thing as this right here? Because the letter's quite arbitrary. Who cares? I mean, he's like
So that's what says X approaches
A,
zero.
B, C, D doesn't matter, right?
U approaches zero. Is that what it is?
Exactly, yes. Because if u equals 5x, and if x is approaching 0, then guess what? That has to approach 0 too, right? Of course. Why would it not? So that's what happens. However, yes, go ahead. Yes. No, it will not, because you're doing sine or cosine. Because sine's your numerator. It will not matter, right? Because numerator is going to, yeah. So for tangent, why does tangent behave that same way? Because isn't tangent x just sine x over cos x? Right? As an identity, we know this. And hence why we beat this into you guys for so many years, because we have to make use of this in calculus. So if you take a limit of tan x or x, isn't that just really the limit as x approaches 0 of sine x over x? Would you agree with that, right? I mean, you got to be very fluid with your fractions, but, sine x over cos x over x, isn't that just sine x over cos x times 1 over x, right? Can we do it like this, right? 1 over x times tan x. You guys agree with that, right?
Yeah.
And then you agree with this. And can I just do a little switcheroo to 1 and sine x? Sure, why not? Of course. And then you guys are the limit properties. We talked about it, right? If you have the individual limits, here we got a product, right? Well, what's the limit of this guy? What's the limit of this guy? 1 also. Because in this case, I could plug in 0. Because what's cosine of 0? 1. So that to answer your question, yeah, that's why it works that way. Yes. So cosine doesn't really matter, right? Okay. Let me clear the board. Okay, this is kind of more of an extension of this whole U sub thing I just started talking about. All right. So here's what I do for this one. Let U okay. Does that make sense? Also, if x approaches 0, then U approaches 0. So when you substitute, you have this, right?
So
Correct. Correct, right. And you have sine U and x is U over 9. Okay, before I move forward, are we okay with that? I just wrote. We're okay with that?
Yep.
What do you think is gonna happen?
Equals 1.
Well, sorry.
Equals 1 9.
Nope. Nope. The answer's 9.
Because sine x basically equals 9. Because.
Well, first of all, let's look at the fraction arithmetic, right? You got flip it though. D over 9.
Oh, because you simplify that.
Yeah, think about it, guys.
Then x equals 0 over 9. Like, if we don't use the line x is 0 over 9. Why would you divide by a fraction? We do that fraction. So that's 9 over u. And sine is just sine, right? But then you could just rewrite it like this. That's okay. There's nothing wrong with that, right? Because then sine u just sine u over 1. Anything can be a fraction, but it's 1. And when you combine them and rearrange fractions, that's totally fine too. Like, for example, if I have 2/3 times 4,
Right? You don't have to write this down, but if I did 2/3 times 4, isn't that the same thing as 4/3 times 2? Right? Who cares? Same thing, right? You can still get to 8/3. So that's exactly what's happening. So we get 9. So as a general rule, this you could write down. We have sine of kx. My k's look terrible, I apologize. And you take the limit. It's just k. It's just k. Now, I'm not going to necessarily have some of that because it's kind of easy. Yeah, my k's look terrible. I failed handwriting as a first grade kindergartner. And so yeah, I never recovered. Yeah. And I kind of see it in my son right now. So he takes after his dad. So anyway, it's K. Yeah. Anyway, I'm terrible with handwriting. That's a good looking K. Yeah. All right. Anyway, but we'll have to use this in other limits when we start doing like more advanced limits. This will be something that we can use in our toolkit. So you don't really have to
Show me this. Like, once you kind of see this baked into a bigger problem, you can just assume that, and that's fine. I'm cool with that.
and we'll get to more advanced limits later on. Okay, here, what do you think I should do for this one? This is a fun one. Not necessarily. I break up the fraction. I decompose a fraction. Yeah, you want to break it up. Bless you.
X squared on the bottom.
Nope.
So the answer is 1, right?
Nope.
Oh, because out the X. Oh,
What's the answer, guys?
4.
4. Thank you. That's totally valid work.
I'm cool with that. Because what you're showing me is that you understand the algebra. You understand that you can go backwards through fractions, right? So you gotta be incredibly fluid with your fractions. Now, this is the reason why.
Some people never make it to calculus or don't really, or they give up. That's because sadly in middle school, they didn't learn fractions really well. Well, what happened 4 or 5 years ago? You guys were in middle school. What happened in the world? COVID, and school was crap. Right? We know that. So hopefully you guys are fraction. I think you guys made it this far, so you guys are fractions are fine. But there's some people who struggle with fractions, and so they have a hard time with this kind of stuff. So you got to be very comfortable. I'm going to be asking you to really just to know fractions in and out, backwards, forwards, sideways, diagonally, whatever. You really gotta be very comfortable with fractions. So notice I broke apart those fractions. Then I have that. Sin x over x we know is 1. We have a 3 being multiplied to it. And I'm cool at that point because now you're evaluating at the third step, and that's easy. So that's sufficient work. Not a problem. Any questions on that one? Let's keep moving. How about this? Why don't you guys try C and D? See how you guys do. I have faith in you guys. The reading I have to do with you guys, for sure. There's no way we're gonna finish these notes today. Yeah, maybe we'll see if we can get to end page 12. We'll see. Go and try C and D. I'll give you guys about 3 or 4 minutes. Yeah.
For C, do you just leave it as like 6 divided by 11 and it's supposed to be? No.
Factor out the x first. Factor the x, guys.
Back out the other.
You don't. You're gonna break apart the fractions. You're gonna decompose. Do you have sine 6x over x? Okay, good. That's 6.
And you still have a larger x plus 3.
Great. Plug in 0. Great. Do it. You're doing exactly what you're supposed to do. Bless you. Bless you too. These problems will be test problems. You can guarantee it. This is what I was saying. You don't need to do the whole use stuff thing. Because it's a pain in the ass. I want you guys to do that. You can just assume, like, okay, cool. I broke apart the fractions. I see this happening. That's 6. That's kx over x. Same thing for d. Sin x over x. Tan is going to follow the same thing too. It's the same. If you had tan 4x over x, you could say 4 if you want to. But anyway, notice I broke this apart deliberately to make sure sine and tan each get an x. So I can use that property. And then of course, e7 5, whatever that is, it's in junk. Cool, go with it.
657.
Cool. Thanks.
All right,
But you can look at the exact form. Yeah, so that's how you get those. Good.
So like if you ever see like sine of 6x over x or like tan, say that is it the answer just it always just boils down to like the ratio.
Correct. Correct.
Even if it's like sine 6x over 2x, that'd still be 3.
Yes, it would.
Can I like do this where I just like do the limit of this, or do I have to keep it as like sine?
Actually, it's kind of weird because now you've already done the limits.
Okay.
So you want to get rid of the limit notation because it's already been done.
Okay.
That's kind of weird. I don't think it's wrong necessarily, it's just strange. Okay, questions? We're good? Yeah, let's keep moving. All right, guys doing great. Here's another fun one. What do you guys think I should do? Yeah. So, because right now, if I plug in 0, that's a problem, right? So we have to algebraically. Now, it's a little funny. So when I do work that out, you wind up getting root let's back up a little bit. Well, sorry, let's slow down a little bit once I finish writing this. Okay.
So let's look at the top. That's kind of weird. Really weird. Let me multiply 4 through 5, 4 through. So now you have 4 through squared, right? Well, if you think about it, I'll just do it on the board because it's kind of strange. If 4 root of 1 plus h times 4 root of 1 plus h. Is that the 4th root of 1 plus h squared? What's that as a fraction exponent? 1 over 4. So if you want to get 1 plus h 2 over 4, which gives you back to root 1 plus h.
So you really just do it again.
Yeah, do it again. I know. That's just kind of cruel. I don't know if I'd do that to you guys. It's kind of mean. Because if you plug in 0, you're gonna have the same problem. You're gonna have 0, 0. And if I work that out,
You some use up
I have to do it both.
for
The 1 plus h or the root for 4th root. Well, how would you do that?
you could
You could be right. I don't know, because maybe I'm just doing this in a more labor-intensive way. You try and you tell us. I don't think so either, but
Could you like raise everything to the 4th power?
no, because you're gonna change the value of the whole expression.
Oh, yeah.
You don't want to do that. No, remember, you have you could multiply top and bottom by like something like we have complex fractions, but no, you don't want to do that. So clear the ones will cancel. So now you have the limit as h approaches 0 of h 4th roots h is canceled still, right? Now I could plug in. Oh, thanks, man. Get 1/4. So yeah, kind of crazy. But you guys are BC honors students. Yeah, anyway. Like I wouldn't do this with a non-AP calculus class. That might be a little too much for them. This is more just pushing you guys a little harder. That's what this problem's all about.
Change the function so that
Yeah,
you can plug in 0 and get it.
exactly. Because you need to get the h to cancel. Right now, the h is the problem.
Oh,
We got to do something algebraically to get that to go away.
Like the h and the
The
denominator.
conjugates are the best way to do it, and well, the only way to do it. Let's William, you got something for us?
yeah,
You do? Really?
yeah, I found some.
Well, tell us. Wait,
It's kind of long. Should I
Okay, well, later because we're a little short on time. I mean, maybe during the quiz I could and then I could share it with you guys on Friday. Okay, we have a little more time before we do a quiz. I'd like to definitely talk about piecewise functions. Yeah, this is good. So probably wouldn't hurt to do a quick sketch Obviously, if I plug in 2, I get 3.
Isn't there no point?
There'll be a hole. It's okay. Put a hole there. Yeah.
Wow.
You
I
said-
didn't know if the whole set X plus 1 or X squared. was
You said.
Both. Both.
They intersect.
Yeah. Well, maybe. I don't know. Let's find out. I don't know. So I'm graphing it.
It's one of them is 2 and one of them is
0.
3, right?
Oh, right. 2. Right. You're correct. Correct. And then the other one, it's a parabola, right? And if I plug in 3, I get, it kind of just keeps going, it keeps rising, right? Hold on. I have to have an endpoint there. Oh, it's a hole again. Darn it. Okay, like that's what? 14, I think. Well, thanks. Yeah, you should believe me. All right, so that's 14. And then if you plug in 4 into the next one, that will be 3, I think. It's included. It just keeps rising, right? Okay, there's your piecewise function. So it just helps to visualize it. What's F2, guys? Undefined, yes. Sure, that's fine. You can say it. F4. 3, right? Now this is the fun part. What's the left-hand limit as x approaches 2? The LHL. Approaching 2 from the left, it's 3. What if you're approaching 4 from the left? 14. What if I'm approaching 2 from the right?
2.
Yep. Well, I'm approaching 4 from the right. Yep. And then is there a limit at 2 itself? There's a limit at 4 itself? No. So pretty easy. There is a way to do this in a TI-4 calculator to graph piecewise. It's a little complicated. Desmos, I just don't feel like doing it right now, but you can. I think we can explore it later. I don't know. Okay, question on example 4. No? All right. Okay, I kind of did this already with you guys the other day. You can rewrite this like this.
So more than -1.
Exactly. Right.
Okay.
Just step out of me, that's all. Yeah, think about it. Absolute value means it holds 2 values, right? So like absolute force. Well, sorry, let me take it back. If you have absolute x, you can do x or negative x, but if you do negative x, then x is negative, right? So for example, absolute force 4, absolute negative force still 4. So to get the same output, you can keep it as is, but assume that the inside's positive, or you can assume the inside's negative, still get the same results. So that's why I made the negative counterpart here, because if x is less than 3, like what's x with 2, for example, right? That'd be -1. What's x by -1? 1. So what manipulation can I do to guarantee the same thing? That's key. What manipulation can I do to guarantee the same thing? Put a negative on the outside. But if I do -2 minus 3, I still get 1. So that's the manipulation we can do to guarantee the same results with absolute value. And that results in this right here, which is a piecewise function or discontinuous at 3.
What manipulation can you do to guarantee the same result as the original function?
Exactly. Yes, that's what you're trying to do. Right. Is that a question, Clay? Or
So is the reason we both like that X is greater than, and then like less than like not inclusive? Is it just because like you get two different answers?
Correct, yes, right. So I approach 3 from the left side of fx, that's of course going to be -1. And if I approach 3 from the right side, I get +1. There we go. So in this case, the limit does not exist if I approach 3 straight up. So so my conclusion, the limit because your LHL does not equal your RHL. That's your conclusion. Yeah, Kevin, good. What was that? Sorry. Well, yeah, but what you really want, but yes, but why is it not continuous? Because the limit does not exist, and that's part of a continuity condition that we have to satisfy. I will ask that later on when we get to continuity, not now. Yes, right. To show me the left hand does not equal the right hand limit, right? Yeah, go ahead. Mhm.
If you're writing a normal, like, function, which of the two parts would include, like the vertex index? I mean, like.
Well, the thing is that it's up to you. You could put which one you want. It's up to you. But in this case, I couldn't include 3 because it'd be divided by 0. But right, if you just straight up write an absolute value as a piecewise, you can put the equal sign to whichever one.
Okay.
It's up to you. It doesn't matter. Or you could just do a separate thing. Say like it equals like 0 at x equals 3. You do that too.
Okay.
Yeah. I think it's a good place to stop here because I can't really squeeze in page 4 of this. So we'll have to save this for another day. So the quiz, just really quickly, in case you guys forgot. In case you guys forgot, go to stat, edit, and you just type in the numbers. All right. After you do that, go back to stat, calc, and select whichever regression I want you to do. And let's say I want you to do an exponential regression. And you need to get the equation. You can store as alpha trace y1 and calculate it, and it'll be in y1. So I'm going to ask you to take some data, give me the regression equation, and ask you some questions about it. So that's, well, like, here's your equation. Now plug in this into your equation. Yeah.
Why do you do it?
Same. Yep. Same.
Dude, you need like,
I do have it, I just really hate using that. Thank you.
all right, like you gotta learn to like it.
I wonder, you know, like.
Yeah.
Do you have it like on you?
So why don't you just bring it to school?
I like using decimals more. Yeah, you're right, I should still.
Seems like up and down. Like I'm not even.
I would just. My phone.
Put it all down.
Like,
Whoa, what? There we go.
And that's why I want it.
Oh, shit.
Really bit lighter, like.
yeah, it's physically.
Hold on, more.
I probably could tell her this way.
Oh my God, that's so like you.
Yeah, yours is literally.
Oh, wait,
And that's not
listen,
comparable.
wait, that's not, okay, hold on.
This is not asking.
Oh, I thought, well, no, 'cause I had to work it out.
Yeah, against parts, yeah.
No, never mind. Okay.
Almost. You know, I just.
No, I don't want to repeat the answer.
Yeah, I agree.
Same thing. Yeah, we're loaded 40 down February. Oh, it's pretty.
What's the shortest line?
There's two sides to it. Oh, good, man.
Everyone's got quiz. Well,
Oh, here's your, okay. That's what they did. Yeah. Get up and clear. Up and clear. Down. I don't think I'm asking that question. Oh, yeah, yeah, you have to natural log. Yeah, sorry. Yeah, sorry. Yes, take the natural log. You guys, please use natural log. For part A. I mean, it doesn't matter, but that's how I'm gonna grade it.
This is my thing look like this.
Was that sorry?
This doesn't look like this.
You doing logistic, dude?
Oh. What should we look at? Oh, oops.
Oh, guys, just round to the nearest whole number. Oh, sorry. Oh, for the equation, do as much as you can. But for B and C, nearest whole number. Right.
You stayed around.
No, I meant for parts B and C. No, your equation should actually be as precise as possible for part A. For your coefficients, be as precise as possible. It's for parts B and C is a rounding. Oh, God. Damn it. I had the answer. Do it over again. Sorry, guys. Just mad at myself. For part A, as many as you can. Whatever you see in the screen, put it that way. Yeah, good. You don't run for part A. I think part A, part B. Yeah, for part A, do the whole thing.
Mine doesn't have a domain. I think I could get corrected.
Really? Yeah. You sure? Hey, Dan. Read the directions more carefully.
You see now? Yeah, go ahead. So say again? Yes, correct. Yes, right. And for parts B and C, you don't really have to show much work. Just give you the answers.
How much you have gone into again?
I'm sorry, say again.
How much you have gone into again?
For part A, just do as many digits as you can. For number 2, for your equation, you could round to 3 digits. That's fine. Yeah, 3 digits. Sorry, repeat that again. Yes. Yeah, sorry I didn't put that. But the rest of the parts are pretty easy. And don't worry if number 2, part A, if the calculator stalls for like a minute, it'll do that. You did nothing wrong. Just be patient. Give me a guess. Go ahead. Oh, yeah.
Yeah, right. Yep. It's really graph though. Yeah. Yeah, exactly. Yeah.
The bell will ring, but you guys can keep going into office hours. You guys, number 2 is pretty fast once you get the equation.
Yeah,
So what about the second question?
Logistic.
it says logistic, doesn't it?
Does it? Let me check. I wasn't sure. Yeah, it says logistic, yeah.